So in our last video, we read the data into R, and if you recall, we just did that with the path and the file name, and then we did a read CSV there. So we've read that thing in, and now we notice that we have some missing values, and we're going to have to do some scrubbing of the data. In this particular case, before we get into fixing some of the missing data, I want to draw your attention to the data sets that we have here. Now, we're working with this guy right here, insurance.csv. Now, in some cases, but not all cases, some cases you're given a data dictionary. So that's something, as we prepare the data for analysis, it sometimes is worth looking at that if it's provided. So if we open this up, you can see here that we were given a definition of all of the all of the different variables here. So this is the two targets. This is eventually when we start building predictive models. This is the stuff we're going to work with. We're going to try to predict whether or not they're going to crash their car, and then we're going to try to predict what it's going to cost us. But this is what the other variables are, and they sometimes have a dictionary that describes those. So it's always a good idea in your career when you are asked to build a predictive model to ask if there's a data dictionary, because that can come in handy. So we will refer to this as we go. So let's start off that now that we've actually read the data in, let's take a look at some of the variables. Now, what we'll do here is we're going to start off by fixing the numeric values. So this will be things like anything that has an integer here. These are numbers. These will be an interval variable. This is going to be a number that we're going to work with. We're going to fix those first. Then we're going to go and try to convert the categorical variables into numbers. So we'll start with this. So if we walk down the path, let's start off by looking at this claim amount here. Now you'll notice that some of these guys are set to 0, are not available. So let's take a quick look at that. Let's do head data frame $, and I think we can do this. We're going to find out. Yep, we got the first 6 values. And you can see that the first 6 values, not available. Then this is the amounts that we paid because the guy did crash his car. Then this guy didn't crash his car, so there's nothing there to do. And then this guy here, we paid $5,900 to fix his car. So we could just do head and do the whole thing if you want here. So you can see this is just the first 6. We've got 10,000 variables. So what we're going to want to do is, in this case, I think I'd like to fix that by saying that this guy is just a 0. In other words, if the thing is not available, then we're going to set it to 0 because the guy did not crash his car, so it didn't cost us anything. So let's do that right now. So to do that in R, and I think I've got that code way down here at the bottom. Actually, I found it. It's right here. So we're going to start off by taking this guy here, and this is our target variable, and we're going to take this command here. And this command is going to say data frame $, target claim amount, and then we are going to look for all of the cases here where this guy is not available, NA. and then we're going to set that to 0. So let's do that first. So let's take this code and as soon as we do this, now if I do head data frame, take a look at that. They're all set to zeros. So that's the easy one to do because that's a target. We don't have to do anything special for that. We're just going to say, you know, hey, if the target is missing, let's set it to 0. We could just throw those records out. That's another option. But in this case, I've made the decision that I'm going to set it to 0. Now, there's no one way to do anything when you're doing data science. You can do, pretty much anything that makes sense and gives you a good result, you can do. I mean, assuming it's legal. You can't do anything, illegal. But as long as you're doing something ethical and legal, if it makes sense, you are allowed to do it. There's not a one single right way to do it. So if you're in your career and you're sitting and you're like, hey, can I do, can I throw those records out instead, the missing targets? Yes, you could do that as well. There's things you can do. Maybe you have a corporate policy that decides on what you're going to do. There's lots of techniques. In this case, we're just going to say that we're going to set the missing value to 0 because we know it was 0. The guy did not crash his car, therefore it's 0. So now let's do some of the easy ones. Okay, so let's go over here and let's take a look at age. Okay, now if you look at the age, summary, I think we can do this, data frame $age. Look at that. We can see that we have a minimum value of 16 because you have to be 16 to drive a car. The median age is 45. The mean is 44.8. We have 7 of them are missing. So let's fix those. We don't want any of those guys to be missing. Now, unlike the target, the rest of these guys are input variables that we're going to use to predict who's going to crash their car. So we're going to do something special here. If we change an input variable, what I like to do is create a new variable that says that it has been changed. So what I'm going to do is my convention, and it's a convention used pretty extensively, is to throw the letters IMP in front of it. Now, IMP means you have imputed the missing value. Imputing means that you are guessing or predicting or estimating what that missing value might be. So that's what imputing means. So we're going to impute this and we're going to create a new variable called impute. Now, what are we going to set that thing to? So if we say we don't know what your age is, we could do a lot of things. We could say, well, if we don't know your age, maybe we can set it to 16 years old. Or maybe we can say that if we don't know your age, there might be a business rule that says we have to assume that you're 60. Who knows? But in this case, I don't know what the business rule is. So I'm just going to say if I don't know your age, I'm going to assume that you are the median age. Now, if you recall, the median age is 45 years old. Let's try that. Let me show you something real quick. Median df $age. You notice when I type in that command, I get NA. Now we know that the answer is 45, but how come when I type in this command directly, it gives me the command NA? Well, the reason why is because there are some missing values here. Remember, we have 7 of them are missing, and R doesn't like those missing values. He doesn't like to do math on things that are missing. So there's a way we can do this is by adding NA RM. So in other words, is we say NA, if it's not available, should we remove those when we're calculating the median? And the answer is yes, we set that to true. So let's do that instead. So by adding this command, NA remove true, look at that. We get an answer. Now I could do anything I want at this point. I could do median. I could do mean. What's the mean? 44. I can do the max. Whoops. Max is 81. The oldest person in our data set is 81 years old. So, okay. So we have just made a business decision that we're going to go with this guy right here. So how do we do that? Well, the way we're going to do that is first we're going to copy this guy. So now we have made a copy. We've taken the data frame age and we've copied him into a new guy called imputed age. And they should be exactly the same. So let's do a, you can see we have, here's our age variable. And now we've got a new guy over here. And he's exactly the same. And if I were to go over here and say summary of the imputed age, or let's just do summary of DF, you can see that the imputed age has 7 of them are missing, just like this guy over here. So I've made a copy of him because I'm changing it. If you're going to change your input variables, you should rename them so that people say, oh, you've changed it. You don't want people to think, you know, because if they pull data out of the database, they're going to expect age to have missing values and certain qualities. But if you're changing it, then what you're going to want to do is you will want to give it a new name. Probably I should have given this guy a new name, but I'm being a little bit flexible here. But this guy I want to definitely give a new name to. Now something else too is I am going to now, if it's missing, so if the age is missing, is .NA, I'm going to set it to 45. So let's do that. So now if I say summary, you can see that age still has 7 of them are missing, but this guy doesn't have any missing. We fixed them all. There's nothing missing. Now we're going to do one more thing. Sometimes the very fact that data is missing can actually be highly predictive when you are trying to build a model. A good example of that is in credit. Sometimes when you say, well, how many times has this guy been late paying his bills? How many 30-day past due lates? Well, you go to the credit bureau and they say there's no record. Well, usually if there's no record and you're trying to get an auto loan or a house loan, if there's no record, it usually means you're committing loan fraud because you should have a record in the credit bureau. So that's the very fact that it's missing is highly predictive of default. So sometimes missing data are highly predictive. A good example of that also is in the short story by the Sherlock Holmes story, where Sherlock Holmes realized that the criminal was the guy who owned a dog. And he said, well, how do you know? He says, well, because the dog didn't bark. The missing data was that the dog did not bark. Therefore, the dog knew the owner, and therefore the guy who owned the dog was the criminal. I probably should have said spoiler alert, but anyways. So we're going to do the same thing here. And I like to, my convention, and a convention that's used pretty extensively, is to put a letter M for missing and age, and the variable. So we're going to create a new variable called missing here. So let's go and put that over here. And so now I have data frame missing age, and then it's going to equal, is it NA? Is it missing? Is it an NA? And then this guy here. So if I do the head command, take a look at that. Here's my imputed age. But look, I've got this new guy here, and it's set to false. Okay, now we don't want falses, we want numbers. So how do we did that again? We did this before by adding a 0 to it, and then R is smart enough to say, oh, okay, wait a minute, if he's going to add a 0, maybe he wants me to treat that as a number. So now if I do this, and there you go. Look, they're zeros. Now, how do I know I did that correctly? Well, remember, I had 7 of them. So if I sum up all of those missing values, I should come up with the number 7. So I'm going to do sum of data frame M age, and I got 7. So look, I had 7 missing, and I fixed them all. Now the last thing you do is we want to get rid of age. We don't need age anymore because we just fixed it. And we don't want this thing hanging around there because it's got missing values. We don't need that anymore. Well, how do you get rid of a variable? You set it to null. So let's do that. And now, if I do head data frame, you can see we don't have age anymore, but we do have these two guys. Now, let's do the same thing a few more times. Okay, so we've fixed the damages. We fixed the age. Let's fix the years on job. We're going to do the same thing again. We're going to say, what is the median age for years on job? So what's the median age? Was 11. Well, first of all, I don't even know if we have to fix years on job. Let's do that. Summary data frame. Years on job. Yep, we got 548 of those guys we have to fix. Okay. So the average time a person spends on a job is 11 years. Now, I happen to know in the insurance industry, when you spend more time on a job, you usually are more stable and you're a less risky driver. So if we don't know how long a person is staying on a job, we might decide that it might be safest for the insurance company to assume the worst. If I don't know how long you've been on your job, maybe I could say 0 years. Maybe you're unemployed. I don't know. So that's something to consider. There might be a business rule as to it being, setting it to some other value. In this case, we're just going to keep it simple and set it to the median. But that's what we can do. So we're going to just take this exact same set of code here. This is the same code that we did with the age, only now we're going to do it with the years on job. We're going to have the imputed years on job is equal to the other guy. And if the imputed years on job, if it's missing, we're going to set it to 11. Then we're going to create this flag variable here. Then we're going to add them all up to make sure that we got them all. And then we're going to get rid of the old years on job. So let's run this code real fast. And now you can see that we no longer have a year on job anymore. But we got it over here, don't we? We've got the imputed years on job. None of them are missing. And we've got this flag variable that we set. and none of those are missing. And when we said how many of them are there, when we sum them all up, 548, look at that. And that's what it was right here. So we know that we did that one correctly. Let's do a few more. Let's do car age. And if we don't know the car age, we're going to set that one to the median, which happens to be 8 years. So let's do that again. We will check to see what the age is. I like to use the median, but you can use any, you can use the mean if you want, or maybe a business rule. But 8 is the years. We're going to have imputed car age is equal to the car age. If it's missing, set it to 8. We're also going to create this flag variable. We're going to add them all up to make sure we got them all. And then we're going to get rid of the old guy. And car age, we had 639 of those guys were missing. Whoops. $639, and if we look down here, we no longer have car age, it's gone. But down here we have the imputed car age, none of them are missing. We have that guy. I think we have a few more, and then we're going to, no, we're going to call it, we're going to stop here because these were the easy ones. Now we're going to go and impute the income next, and we'll do that in the next video.